Okay, now my topic of discussion with you is value at risk. Okay, value at risk are very famously called VaR. Okay, basically measures the maximum potential loss, a company might incur, a company, a bank, a financial institution might incur over a certain time period. Okay, time period. So the way VaR is expressed is, say for example, I might calculate a 90-day VaR for a bank. Okay, of the bank, let's say, is rupees 50 crores. Okay, it means that there is a 95% possibility. I'm assuming the test is being done at 95% confidence interval, which is a normal, uh, you know, uh, confidence intervals that is used by banks also. There is a 95% probability that the maximum loss, okay, from the assets, that is for a bank, assets are loans given, right? From the assets in the next 90 days or 3 months will be rupees 50 crores. Okay, another way to interpret this is, okay, there is a 5% probability that the loss will be more than rupees 50 crores. There is only 5% probability that my loss will be 50 crores in the next 90 days. Okay, this is how you can understand VaR. Okay, VaR can be applied on portfolios also. For example, I am running a portfolio, stock portfolio, and I can determine the VaR for the portfolio at, let's say, 50 crores. That means I have a portfolio of, let's say, 100 crores or 1000 crores. In the next whatever 90 days or 1 year or 6 months, the loss from my portfolio would be X amount. That amount is VaR. Okay, that is what it is. Now I'm going to show you how we can calculate that in Excel. Okay, so let's do that probably here. We'll do that here. Firstly, let's write down the exposed asset value. Okay, I'm talking about exposed asset value, keeping it neutral. It could be a bank, it could be a portfolio manager, it could be a NBFC, it could be anybody who has an asset whose future returns or future price or value is fluctuating. Okay, let's assume some number, 100 crores, 100 millions, whatever it is. So let's say this is the total assets value, or maybe loans given, whichever way you would like to understand. All right. So expected volatility, which is basically the standard deviation. So any of these assets, we need to find a way to determine the standard deviation of its value. Okay. For example, it's very easy in case of a portfolio, because portfolio standard deviation can be calculated using the historical standard deviations of the stocks. Okay, so I'm keeping it as historical standard deviation. Okay, analyzed standard deviations will take, let's assume it is around 20%. But for a bank's case, that historical standard deviation may not be possible. You might have to use a different method to determine the standard deviation, but standard deviation is a must. Okay, so that is why there are 3-4 types of VaR calculation. Okay, VaR computation type. Okay, one, there is a historical VaR, which is what we are working now. Okay, then there is a simulation VaR. Okay, so basically you apply something called a Monte Carlo simulation to determine the standard deviation, or you can also use econometrics. Okay, econometric VaR. So basically you will use something like a arch-garch kind of models. Okay, to basically predict the volatility. Okay, as of now, let's not worry about that. We are going to use the historical standard deviation, and I'm making an assumption that you understand the meaning of standard deviation. Okay, now for how many days do I want to predict? Okay, how many days I want to predict the VaR? Okay, let's say 90 days. I want to calculate the VaR for the next 90 days. Okay, and at what confidence level would I like to calculate my VaR. Generally, it's a normal practice in financial markets to use a 95%. Okay, so this is basically, I'm asking what should be my accuracy of VaR estimate? What should be my accuracy of the VaR estimate? Okay, that's basically the information I need. Using this, I can find out, firstly, let's find out the Z table value. Z table value. So Z table value, okay, okay, we can use norms inv. Norms inv is a function. What norms in does is, if you give the probability, say I'm giving 95% probability, right? Okay, 95% probability. So for 5% probability, what is the table value that I want to get? I'm sorry. We will get it for 95%. Yes. Yeah. 95%, 1.64. Now I'll put a minus value to this. One second. Let's not put minus here. Let's do the same thing. 1 minus 95%. I want to find the probable Z table value for a probability of 5%, which is minus 1.64. Okay. So let me get this here. Yeah, I'm using the norms in function. So this gives me the Z table value. So how is VaR calculated? Okay. VaR. How is VaR calculated? So basically it's a simple formula. Z multiplied by the standard deviation. Okay. Now when I'm taking the standard deviation, remember this is for an annual, it's an annual standard deviation, but I want it for 90 days, right? So therefore we need to do standard deviation multiplied by square root of n. You have to do square root of n. Okay, remember that. It's an adjustment for the standard deviation. Okay, maybe I can say annualized standard deviation multiplied by square root of n. Okay, so I'm going to incorporate that function here. All right, watch this. So let's take z multiplied by the annualized standard deviation multiplied by square root of 90 by 365. Okay, that's it. So this gives me the VaR number of minus 0.16335. Okay, one second. Okay, so that's basically how I calculated. So this is basically percentage reduction. Okay, so I'm saying the VaR percentage in terms of percentage will be, there will be a reduction of 16.3% from my assets in the next 90 days. Okay, so if this is so, VaR value will be 100 crores is my total assets. Multiply that with 16.3 percentage. Okay. So this is in terms of rupees crore. Okay. In rupees. Okay. So I am saying, how do we interpret this? We say we are 95% confident that the maximum loss from the assets over the next 90 days will be rupees 16.34 crores. Yeah. So that is what we mean. Now, say for example, instead of 95%, I want a 99% confidence interval. So then I will say I'm 99% confidence that my maximum loss will be 23 crores. Okay. So you can change this, or if the standard deviation changes, if the asset value changes also, you can determine. Okay. For argument's sake, okay, just for argument's sake, let us take some real life portfolio and we'll calculate the VaR for it. Okay. So let's do that. I'll take some mutual fund company mutual funds. Okay. Maybe we can say HDFC fund fact sheet I'll take. Okay. Let's see. Okay. HDFC fund fact sheet. Let's choose any one of their funds. Okay, I have fund here, HDFC Mid Cap Opportunities Fund. What is their value, asset value? They have around 77,682.90 crores. Okay, this is their total asset value. Their standard deviation is, portfolio standard deviation is given here, which they say is 13.448 percentage. This is historical standard deviation, of course. And we want to see how much will be the maximum loss that one can expect from this portfolio over the next 90 days. If you see at 95% confidence interval, I would say around 8,532 crores or around 11%. This is maximum. Please don't assume that I'm telling there will be a, I'm not predicting market here. I'm not predicting the loss. I'm saying worst case, this will happen. Correct? If at all market falls and this stock falls, or this fund will go down. If the worst case happens, this is the maximum loss that will happen. Okay, I hope you're not misreading what I'm saying here. All right. So that is basically, for the portfolio VaR that we have calculated. All right. So that's about it. Okay, that's how VaR is computed. As I told you, the improvement to this model would be to come out with a better estimate of the volatility of the asset. Okay. So for instance, we can do this for the stocks also. Let me try this. We just let's go to, let's say, NSE India. I'm going to NSE India. Let's take, for example, Reliance stock. I'll take a Reliance stock. All right. So the stock price of Reliance is 2,713.30 now. I'll replace this value. Okay. The volatility of Reliance stock price, NSE gives you that information, by the way. Yeah, you can check out here. Annualized volatility, 26.36%. Okay. 26.36%. This is as per NSE's computation based on the last 1 year daily closing prices, 26.36%. So worst case, I'm saying, worst case, you can expect the Reliance stock price to fall by 21%. Okay, based on the kind of a fluctuation that the stock is. You see, VaR, as a concept can be applied either if you're a bank or a financial institution, you can predict how much will be the maximum defaults. You may, if you're running a portfolio, you can determine how the portfolio will, fall, maximum it will fall. And on the other side, you are talking about how much the stock price might fall also. All right. So that is basically the concept of VaR. And I think that was helpful for you. So thanks for joining.